Okay, number 15. If you haven't done this, like I said on the last one, go do it and then come back and check this out. And so, reading it carefully, let's try to figure out if we could find out if it's confidence interval, um, hypothesis test, one or two sample, or proportion or means. So, study published. Researchers wanted to measure the effect of alcohol on the development of the hippocampal, I think, region of adolescence. The hippocampus is a portion of the brain responsible for long-term memory storage. The researchers randomly selected 12 adolescents with alcohol use disorders. They wanted to determine whether the hippocampal volumes in the alcoholic adolescents were less than the normal value of 9.02 cubic centimeters. An analysis of the sample data revealed the hippocampal volume is approximately normal, with a mean of 810 and standard deviation of 0.7. Conduct an appropriate test. Okay, so we know it's means because I'm talking about the average. Uh, I'm sorry, right here. The average is 810. Okay, so means one sample. And what are we trying to show here? Okay, conduct a test. What test? This one right here. We want to determine whether the volumes in the alcoholic adolescents were less than 9.02. Okay, because that's the non-alcohol uh, hippocampal volume, and then we want to test to see if it's less. Okay, and what's my evidence? My evidence is that X bar is 8.10, S is 0.7, N is, what did they say, 12? 12 kids. Okay, so if I do this test, I have to check my conditions, and it has to be a random sample. This really isn't necessarily random. Well, it says they did check it, but oftentimes for volunteers for studies, they're volunteers because we have to deal with volunteers. Um, so we try to make sure that the biases that they have don't apply to the experiment that they're in. So we got a random sample, and n has to be bigger than or equal to 30, which it's not. But we do have stated that the population, not the population, the sample data is normal, because see, population is not normal. They didn't say that, but I know the sample is normal. And if the sample is normal, that's evidence that the population is normal. Okay, so let's do the test. This is a t-test. So t and a p-value. Because a t-test is for means. A z-test is for proportions. So if we do this, pull this over here, t-test. The mean was 9.02. My sample is 8.10. Standard deviation is 0.7. N is 12. And we want to know if it's less than this. So we want to know, is my 810 with 12 people far enough out there that the real mean is that gives me evidence that the mean is really smaller than normal. And according to this, t is negative 4.55 and p is 4.13 times 10 to the negative fourth, so 0.0004. Let me double check that. Yep. Okay, or 0.04%. So that's very unlikely to happen by chance. In other words, another way of looking at it is, I've got a sample of 12 with a volume of 8.10. The chance of that happening, or smaller, is 0.04%. Don't buy it. Didn't happen by chance. So therefore, the true population of all kids that drink alcohol is less than 9.02, which is the normal. Okay, so conclusion, since the p-value equals 0.04% is less than, they want us to do it at the 1% level, I have evidence that the mean volume of, of adolescents, um, let's say alcoholic adolescents, with alcohol disorder is actually have evidence that the mean volume of adolescents with alcohol disorders is less than 9.02% or 9.02 cubic centimeters. Okay, this is too unlikely to happen by chance. So what's the reason for it? The true population of all kids with alcohol disorders is less than that. So yes, it does have a negative effect. There we have it.